Section 1, Average Rate of Change. So, this is our very first calculus section of the year. It's actually on the AP test. It's something we have to worry about. And it's also something we've been doing since pre-algebra. When was the first time you were asked about slope? This is the find slope section. Now, the reason we care about this is because the derivative is the instantaneous rate of change, and to approximate the instantaneous rate of change, we actually use average rate of change and zoom in to the very point which becomes instantaneous rate of change. And so finding the average rate of change can help us get to that point. So, the way we do this is, well, we're trying to find the approximate solution to f prime of -4 in this first question. We're given this table here. So to approximate -4, well, -4 is the x value in between -3 and -5. And so I'm just going to find the slope between -3 and -5. So all I do is 97 minus 55 over, same x value comes first, -3 minus a -5. And I get 2 on the bottom for -3 plus 5. And on the top, I get 97 minus 55, which is 42. And so this is 21 for our approximate solution to f prime of -4. Now, you might notice in the question, I solve for slope because I saw average rate of change, but I also solve for slope because it asked me to approximate the solution. They're going to ask for average rate of change in a lot of different ways, and you just kind of need to pick them up as we go through them. But approximate solution is a very common case where they're going to have us do this. And in the next question, find the average rate of change. This one actually specifically asks us to do it. So what we're going to need is we need y2 and y1 and x2 and x1. Well, we already have x2 and x1 here. That's 8 and 1. Those go on the bottom. And now I just need f of 8 and f of 1. 1. So I'm going to figure these out. F of 8 is 2 times 64, which is 128, minus 48. So 128 minus 48. That's what 6 times 8 is. F of 1 is going to be, I'm going to plug 1 into this. 2 minus 6 is -4, so we're subtracting a -4. And we're all over 7, because that's what 8 minus 1 is. All right, so 128 minus 48 is just 80, plus 4 is 84. So this is 84 over 7. And 84 over 7 is just 12, and we've done it. Now, neither of these questions had units, but we're going to have questions with units. So I went to the 2012 released AP free response questions. So this is an actual AP free response question down here. And here's where average rate of change shows up on the AP test. We're given minutes in degrees Fahrenheit and some different values here. And it says use the data in the table to estimate, so the same word as we had in that first one, W prime of 12. Now, show the computations that lead to your answer. Using correct units, interpret the meaning of your answer in the context of this problem. So not only do we need to solve for the slope between the values that are around 12, but we also need to use correct units and explain what it means. So let's do the question first, the math part. 12 is between 9 and 15, so I'm going to use those values. 67.9 minus 61.8 all over 15 minus 9 for y2 minus y1 over x2 minus x1. And I get 6.1 over 6. Now on the AP tests, you're actually totally fine leaving your answer like this. This is beautiful. What I'm missing, though, is the units, which I said I was going to do next. So I'm going to do the units now. Degrees Fahrenheit per minute. Now, okay, I have to do the next step, which is using correct units, interpret the meaning of this. So what I'd say is that the temperature is increasing because it's a positive rate at a average rate. Now they did say estimate, so we can go back to the average rate of change and use average rate as our keyword, of 6.1 over 6 degrees Fahrenheit per minute. And, at time equals 12. And that's a pretty good way to answer that question. All right, so average rate of change, what it is slope. How it's asked is very different depending on the context of the problem. Sometimes we're going to be directly asked for average rate of change. Sometimes we're going to be asked for to estimate the derivative, as we were in both our first and our third examples. Sometimes they're just going to ask you find the approximate velocity and give you a whole bunch of distances. Sometimes they're going to ask you for the average acceleration and give you a whole bunch of velocities and times. So the hard part of these is how they're asked and discerning whether or not you need to use the tool. And that's it.